Good morning. This lesson is for my Trig-Precalc class, but before I get started, I want to say I hope everyone is doing all right out there. I don't remember what lesson it is. I do know it's chapter 3, but it doesn't matter. So let's go ahead and jump into our goals. I want to reteach this lesson because I think I can explain it better than I did the first time, and I really want to do better at it than I did the last time. So let me go ahead and talk about our goals. Our first goal is we're going to use coordinates we know on the unit circle to find values of tangents. Our second goal is to use our graphs of sine and cosine to figure out the rest of the graph of tangent, along with calculations that support this. Now, there's a lot going on this whiteboard, and I'm going to try my best to explain what we got here. All right. So, first of all, in red is a graph of my sine. Remember, sine is the y-coordinate on the unit circle, and the input, which is the x value, is the length on the unit circle that I travel along to get to that ordered pair, and these heights are the y values at that ordered pair. And notice I have a couple y values calculated out. Square root of 3 over 2, that's roughly 0.85. Square root of 2 over 2, that's roughly 0.7. 1 is 1, and 1/2 is 0.5. The purple graph is cosine. Again, these are the output is the x-coordinate, and those are the heights, and these are the lengths around the unit circle. Remember, if I'm going negative, I'm going in a clockwise direction. So these are the lengths around the unit circle that I travel to get to ordered pairs, and these are the heights are the x-coordinate on that unit circle. So we get what's called a wave function. Okay. Again, cosine is even, because I have a mirror image along the y-axis. Sine is odd because if I go equal distance left and right, I get the same heights. And so hopefully that reminds us what these graphs were about. Tangent is defined as sine over cosine. And remember, sine is a y-coordinate and cosine is the x-coordinate. And I have a table here, but before I jump into the table, I want to remind you something about fractions, right? Because we're going to have a lot of fractions over fractions, because y-coordinates and x-coordinates are fractions for most of the ordered pairs around the unit circle. So if I have a fraction of a over b divided by a fraction of c over b, notice the denominators are the same, and that's true for every fraction that we have in the ordered pairs that we're working on in the unit circle. I need to get rid of this fraction in the denominator, so I multiply by its reciprocal, b over c, and I divide that, or b over c divided by b over c, and what I'm technically doing is I'm multiplying by the number 1, and I wrote the denominators reciprocal, so it's going to cancel out the denominator. So that cancels, that cancels, that cancels, that cancels, this cancels, this cancels. I'm now left with a over c divided by 1, which is just equal to a over c. So a was the numerator in the top fraction, and c was the numerator in the bottom fraction. And so you can just put the numerator on the top divided by the numerator in the bottom, and that's what I've done in this chart. So I wanted to explain how I got some of these values before I jumped in. So for this value, and this value, I'm using this concept. All right, so now let's start plotting points on this graph of tangent. I'm going to use green for tangent. And where did I hide my green marker from myself? It's over here. All right, so at a length of 0, my ordered pair is 1, 0. So my y-coordinate is 0, my x-coordinate is 1. So tangent at a length of 0 is 0 divided by 1, and that's 0. So my value of tangent right here is 0. Okay, so it's basically the height of the sine function. The height of the sine function divided by the height of the cosine function. So it's 0, right? Because the sine function has no height. At a length of pi over 6 around the unit circle, I get to the ordered pair square root of 3 over 2 and 1/2. Now remember, it's my y-coordinate over my x-coordinate. And again, notice I have the same denominator, so I have this. So I can take my numerator from my y and put it over my numerator from my x, and I get 1 over the square root of 3, which is roughly equal to 0.6. So at a length of pi over 6, my tangent has a value of 0.6. Okay. Go a little farther around the unit circle to pi over 4. I have square root of 2 for my x-coordinate, square root of 2 over 2 for my x-coordinate, square root of 2 over 2 for my y-coordinate. So at tangent of a length of pi over 4, I get the numerator, this is complicated. I get the numerator from the top fraction divided by the numerator from the bottom fraction, and any number over itself becomes 1. So at a length of pi over 4, I get a height of 1. And this makes sense because both my sine and my cosine graphs have the same value, so any number over itself becomes 1. Alright, so let's see here. At a length of pi over 3 around the unit circle, these are my coordinates. So it would be the numerator of my y value divided by the numerator of my x value. And I get a height of 1.7. So at pi over 3, I get a height of 1.7. And to be honest, these are the 1, 2, 3, 4, 5 values that we really need to know. And let me talk about the last one here. At pi over 2, at a length of pi over 2, my y-coordinate is 1, my x-coordinate is 0. So I'm going to divide 1 by 0, which is undefined. We get a vertical asymptote at pi over 2. And in fact, anywhere my purple graph hits the x-axis, I'm dividing by 0 because that's the height of my y-coordinate, or my x-coordinate, right? So I'm going to draw a vertical line through pi over 2 to indicate that I have an asymptote. I'm sorry I'm blocking this. And again, anywhere I have my purple graph crossing the x-axis, I can draw an asymptote because that's where I divide by 0. Remember, we want to use the graphs to understand the graphs of sine and cosine to understand the graph of tangent. Okay. I crossed right here as well. So I can draw a vertical asymptote through here. And remember, asymptotes are values that we can't get to. And I'll have one more vertical asymptote on this graph. I can also use the sine and cosine anywhere else in this graph to figure out where my 4 tangent points are. I know where the undefineds are. I can now find the other points in the rest of the graph. Now I want to point something out here. We went from 0 to pi over 2. From 0 to pi over 2. My purple graph is above the x-axis and my red graph is above the x-axis. And so I'm dividing positive by positives. Right here, from 0 to negative pi over 2, my red graph, which is my sine graph, my numerator, is now negative. And my denominator, my purple graph, is positive. So on this side, I'm dividing a negative by a positive, so every outcome is going to be negative. So I just have to draw the mirror image on, actually the odd version of this, on this side of the y-axis. So at a length of negative pi over 6, my tangent graph is at negative 0.6. Okay. At a length of pi over 4 on this side, my tangent graph has a height of negative 1. Right. At a length of negative pi over 3, my tangent graph has a height of negative 1.7. And I can work my way through this again. And in fact, this pattern is going to repeat all the way through. So at a length of 2 pi over 3, my x-coordinate is negative 1/2, and my y-coordinate is square root of 3 over 2. I just have this version of the ordered pair with this being negative, right? Because it's negative because it's below the x-axis. So I know from here to here, my tangent values are going to be negative because I have a negative dividing into a positive, right? So I can find these points and I'll plot them really quick. Negative 1.7, negative 1, and negative 0.6. Anywhere my red graph crosses the x-axis, tangent is equal to 0. Now, I have both my sine and my cosine being negative, so that means the tangent is going to be positive because I'm dividing a positive or a negative by a negative. So here I go to 0.6. And again, I'm just using these ordered pairs, but now both the x and y coordinates are negative on the unit circle from pi to 3 pi over 2, right? So 5 pi over 4, that means I'm at 1. And 4 pi over 3, that means I'm at 1.7. So hopefully you're seeing that this graph has a repeating pattern every time I get to another side of an asymptote. So far, 5 pi over 3, so now the x-coordinate's positive and the y-coordinate's negative, so it would be again below the x-axis because I'm dividing a negative by a positive, my outcome will be negative. How am I doing on time? Oh my gosh, this is a long lesson. All right, here we go. So negative 1.7, negative 7.4, that's 1, and it's 6, and it's 0. Hopefully this is making sense to you guys. I want to now just focus on this piece. Okay, so I have 1, 2, 3, 4, 5, 6, 7 points for tangent. That's enough points to get a concept of what's happening, but I want to talk now about my second goal. And the second goal is we're going to use our graphs of sine and cosine to figure out the rest of the graph of tangent along with the calculations that support this. So what I want to point out, again, the purple graph is my denominator, the red graph is my numerator, and the height of the graph is what we're plugging in, right? So here I have, as I get closer to this length of pi over 2, the height starts to get closer to 0. So I'm starting to divide by a smaller and smaller number, which is the same idea as using a smaller and smaller spoon. The smaller the spoon that you use, the more scoops that you have to take, right? So as this purple graph gets closer to pi over 2, I'm dividing by a smaller and smaller number because the height's getting shorter and shorter and shorter. This is getting closer to 1. So my spoon is starting to get tinier and tinier, so I have to take more and more scoops, right? And so what we want to understand is what's happening to the tangent graph is A is getting closer to this length on the unit circle. What happens to the height of sine divided by the height of cosine as we get closer to pi over 2, where the height of our denominator is getting closer to 0. And so pi over 2 is the same as 1 pi over 2, and a number close to 1 pi over 2 is 0.9 pi over 2. And if I plug in 0.9 pi over 2 into a tangent function, I'm going to get 6.31. So my value very close to this is already off the board. If I was to go 10 times closer than this, that means I'm going to get a value that's 10 times higher. And if I get even closer still to this, 10 times closer than I was previous, 100 times closer than I was previous, that means I'm going to now have a height roughly 10 times higher than that, or 100 times higher than this. So what you can see here is as I get closer and closer and closer to where this crosses the x-axis, my denominator function, as it gets closer and it gets smaller, the spoon gets smaller and smaller, which forces the result to get larger. Here I needed 6 scoops to empty the tub of ice cream. Here I need 63. Here I needed 631. So imagine you have the same size tub of ice cream, but you keep having to use a smaller and smaller spoon, right? So you can see that a very tiny distance closer to what we thought was close means that we have to do quite a bit more scooping. 6 scoops is not that bad. 1, 2, 3, 4, 5, 6, and a third scoop. Imagine now having a spoon so tiny, what once took you 6 and a third scoops to get rid of, now it's going to take you 631 scoops. So what's going to happen is the height of tangent is going to explode as we get closer to this because I'm dividing by a smaller and smaller number. So from where my graph crosses, I'm going to get something that looks like this. And it's just going to explode and get close. Now here on this side, I'm going to have the same kind of behavior, but here I have the positive number getting very tiny, dividing into a number very close to -1. So as I get on this side of as I get on this side of where my sine graph crossed the x-axis, where it went from positive to negative, I'm going to have tangent explode into a very tiny negative number the closer I get to this, because again, the closer I get to this, the smaller number I divide by, which makes the numerator value, or makes the output value explode, but we're going in the negative direction again, because I have a positive height dividing into a negative height. So hopefully this clarifies this lesson for you and gets you to realize that how I'm looking at a graph and I'm using the understanding like, oh, my denominator is getting close to 0, so it's going to explode the value. My denominator is getting close to 0. As a negative number, this is also negative. So I know that with confidence it's going to explode up here. I got a positive and I got a negative getting close to 0, so that's going to explode in this direction. So again, hopefully this helps to clarify this very difficult concept to wrap your mind around. But again, we want to start thinking about what happens as we get close to a value. And I'm going to go ahead and end it here. Have a good rest of the day, everybody. I'll see you later. Bye-bye.